Welcome to Phase Holographic Imaging. Most cellular and intracellular events occur in 3 dimensions over time. An ideal technology should allow to monitor cellular dynamics in live cells as a function of time in a minimally invasive way while permitting automated quantification of cellular features. We are pleased to introduce breakthrough label-free holographic time-lapse imaging cytometry, HoloMonitor M4. HoloMonitor M4 utilizes the principle of holographic microscopy. A low-power laser beam is split into 2 beams, one illuminating the sample and the other providing a reference beam. Laser light passing through the sample is affected by intracellular structures, causing a phase shift of the illuminating light. Once combined, the 2 beams create an interference pattern that is recorded by a digital image sensor. The interference pattern is then processed computationally to produce a holographic image. The fine focusing of holographic microscopy is done entirely in software after recording. The digitally recorded interference pattern is computationally processed to create holographic images over a range of focal distances. From this temporary stack of images, HoloMonitor M4 automatically selects the best in focus image to produce the final holographic image. Alternatively, users may manually select the focal distance to focus on a plane of interest. For example, mitotic cells that are a plane higher than the sample average. Digital autofocus is an important feature. It makes HoloMonitor M4 insensitive to focus drift and allows images to be refocused after recording. The foundation of quantitative analysis is the ability to identify discrete events for quantification. In the line profile of the traditional phase contrast image, the background value cannot be accurately determined, and a characteristic bright halo around the edge of the cells is present. This type of image does not lend itself for reliable segmentation. In contrast, holographic images can be quantified as they reflect the optical thickness of the cell and optical density variations in the specimen. Additionally, holographic images have background level of 0 and the intensity of the events measured as positive values. HoloMonitor methodology enables reliable segmentation. Seen in the image as yellow cellular boundaries defined by a proprietary software algorithm. From the segmented events, a wide variety of quantitative features are calculated. The most fundamental are area, optical thickness, optical cell volume, irregularity, and texture. And now, let us demonstrate the HoloMonitor M4 workflow. The operation is simple and is powered by intuitive proprietary software, Holo Studio. There are no focus or objective controls, so the only step is to position the vessel on the mechanical stage and select the field of view. The data storage features a 2-tiered approach, allowing the definition of a project and separate image sequences related to the project. The total recording time and time interval between image captures are determined. Both short-term monitoring of transient events in second intervals and multi-day studies with images captured at user-defined intervals are possible. Images can be displayed in grayscale and color, 2D and 3D. Adjusting threshold allows digital filtering of cells of interest, mitotic cells in this example. Individual thumbnail images of the data set can be selected for viewing. Once time-lapse videos have been recorded, various analysis choices can be considered. The process starts with selecting one of many available segmentation strategies. The suggested segmentation is fine-tuned by adjusting background threshold and optimizing cell size. The segmented cells can be individually selected to simultaneously track cell movement and changes in cell morphology over time. Individual cell movements are displayed in spatial plots with related quantitative parameters, such as cell motility speed and cell migration velocity. Tracking of related measured morphological parameters is done automatically. Here, we are following changes in optical cell volume over time. As an example, mitosis and cytokinesis are robustly measured by HoloMonitor M4 in a label-free manner, with results comparable to traditional fluorescence imaging instruments. When cells proceed through cell division, the morphology changes from flat to round, with a corresponding increase in optical cell thickness and optical volume. Then, the nucleus splits in half, and the cell divides into two new daughter cells. The segmentation algorithm recognizes the daughter cells as individual events based on the sharp decrease in optical volume, enabling computer-assisted tracking of mitotic cells. Further, comprehensive automated analysis is performed automatically, with options to display quantitative and morphometric features in two-dimensional histograms and scatograms. Data verification is done based on images. As we point to an event in the scattergram, the frame that contains the event is displayed. The crosshairs identify the specific events. In this example, mitotic cells and post-mitotic cells. Corresponding quantitative parameters are simultaneously displayed in the insert. Cells of interest can be gated and color-coded. The red region is defined around mitotic cells, and the green region is defined around post-mitotic cells. Cells from the regions are color-coded in the images, and corresponding region statistics are displayed. Once the regions are color-coded in a scattergram, the colors are carried through for all the events in the region and to all scattergrams. Finally, the time-lapse movies can be viewed and effortlessly exported, a functionality beyond the capabilities of many alternative systems. The acquired images can be easily saved in common image file formats. Additionally, data can be exported as XML. Or to Excel for further analysis. As an extra added benefit, the images can be easily processed in multiple freeware programs. HoloMonitor M4, an essential and versatile tool for label-free kinetic cell analysis. The low-intensity, single-wavelength laser generates no heat and reduces the risk of photo damage to an absolute minimum. As samples are analyzed unstained, no sample preparation is required. And most importantly, cellular function is not altered by toxic stains. The incubator-tolerant design makes HoloMonitor M4 especially well-suited for long-term kinetic cellular analysis. Quantitative phase shift measurements are translated by sophisticated software algorithms into morphological parameters, optical cell volume, thickness, texture, and many more. Images can be refocused digitally after recording. Many different sample vessels can be analyzed, from chamber slides to petri dishes and culture flasks. HoloMonitor M4 offers a revolutionary way for studying cellular dynamics in real time, from simple cell counting to comprehensive cell tracking. It enables the next level of insight into real-time analysis of cell cycle and cell death. It has become an indispensable tool in quantifying rare and transient cellular events. HoloMonitor M4 for competent and powerful discoveries.